Hello everyone. I, Nikita Shinde, along with my coordinator Parul Shinde and Jayashree Shinde, studying in final year B Pharmacy from Shivajirao S. Dondarai College of Pharmacy, we are here to present you with the topic of hard gelatin capsule under the guidance of Dr. Nitin Mohere, professor and principal of our college. So let's start. Capsule. What are the capsules? Capsules are solid dosage form in which one or more medicament or inert substances are enclosed within a small shell or a container, generally prepared from a suitable form of gelatin. Advantages of capsule. Capsule can mask unpleasant taste and odor. They are easy to administer. Sustained release can be achieved through capsules. Capsules are economical. They are dose precise. They are easy to carry and handle. There are some disadvantages to capsules, and they are: capsules are not for highly deliquescent or efflorescent material. They are not tamper resistant, and special conditions are required for the storage of capsules. Moving on to type of capsules. There are two types of capsule: hard gelatin capsule and soft gelatin capsule. Hard gelatin capsules are cylindrical in shape. These capsules consist of two parts, that are body and cap. Plasticizer and gelatin ratio in this capsule is 0.4:1. Boundary wall is firm and rigid, and they have less preservatives. They usually comprises solid materials. In soft gelatin capsule, these capsules are generally round, oval or tubular in shape. They consist of only one piece. The plasticizer and gelatin ratio in these capsules is 0.8:1. Boundary wall is soft and flexible. They have more preservative compared to hard gelatin capsules. They comprises liquid or semi-solid material in them. Capsule size. There are 8 sizes of hard gelatin capsules that are commercially available. Most widely used sizes are from 0 to 4. Capsule size 00 and 000 are preferred for veterinary use. Capsule fill weight is equal to tap bulk density of formulation into capsule volume. Here is the representation of capsule sizes. Types of hard gelatin capsule. There are generally 4 types of hard gelatin capsule. The first one is snap fit capsule, the second one is cone shaped capsule, the third one is star lock capsule, and the fourth one is locked capsule. In this diagram, we could see different parts of the capsule: body, shoulder, snap fit groove, cone cut, pre-lock notch, dome, cap, air vent, cut edge, dimple, snap fit groove. We could also see pre-closed and closed view of capsule. So now let's see manufacturing part of the capsule. Manufacturing of hard gelatin capsule. Manufacturing consists of 6 stages. The first one is dipping, second one is snipping, third one is drying, fourth one is stripping, fifth one is trimming and joining, and sixth one is polishing. In this diagram, we could see different stages from dipping to joining. This is a schematic representation of manufacturing of capsule. Dipping. The pair of stainless steel pins are dipped into the dipping solution to simultaneously form cap and body of capsule. In spinning, the pins are rotated to distribute gelatin over the pins uniformly and to avoid the formation of bead at the end of the capsule. Drying. The gelatin is dried by the blast of cool air to form a hard shell. The pins are removed through a series of air drying kilns to remove water. Stripping. A series of brown jar strips the cap and the body portion of the capsule from the pins. Trimming and joining. The stripped cap and body portions are trimmed to the required length by the stationary knives. After trimming to the right length, the cap and the body portions are ejected and joined from a machine. Polishing. A silicone pan is used to dust and polish. After polishing, the capsules are rubbed with the cloth. Capsules are fed a soft rotating brush for polishing. Packaging and storage. Capsules are packed and stored in polythene lined fiber drums or cardboard box in heat sealed polythene bag. Finished capsules normally contain an equilibrium moisture content of 13 to 16%. To maintain the relative humidity of 40% to 60% when handling and storage capsule is required. Empty capsules should not be subjected to temperature above 38 degrees Celsius. Empty capsules should maintain moisture content between 12 to 15%. Standard of hard gelatin capsule. The first one is dimension, the length of the individual cap and the body. The length after closing two halves of and diameter of cap and body are critical. Second one is solubility. Empty capsule remain undissolved after immersion in water at 25 degrees Celsius for 15 minutes. Moisture content. Moisture content should be normally between 13 to 16% to prevent brittleness, determined by drying at 105 degrees Celsius. Odor. The capsule shell must be free from any foreign odor. This is determined by checking a sample after storing in a sealed bottle for 24 hours at 30 to 40 degrees Celsius. Filling of hard gelatin capsule. Trimming and joining. Filling of hard gelatin capsule. Capsules are filled with powder, pellet mixture, pellet type 1, pellet type 2, tablets, solid plugs, capsules and pastes. Various types of filling methods are plate method, auger feed method, dosator feed method, dosing disc and tamping finger method, and vacuum filling method, fluidizer method. In this picture, we could see capsules filled with powder, granules, beads and tablets. Plate method. When the powder is formed for a certain size of capsule and is for reasonably uniform density, the material is spread over the capsule body to fill them completely. The excess powder remains after the capsules are filled is removed before placing the cap. The machine that works on these principles are Tevopharma, Bonabac. This is the schematic representation of plate method, capsule filling method of capsule. Auger filling principle. Powder or granules are contained in mass flow hopper with rotating auger. Example of machine: Lilly, Parke Davis and Elanco. Powder is fed continuously out of the hopper outlet due to the rotation of the auger. The amount of powder fed into the body depends on the time capsule body spent underneath the hopper outlet and auger speed. This is the schematic representation of auger filling method. Next method is dosator feed method. It consists of cylindrical dosing tube fitted with movable piston. The position of piston is present to a particular height to define a volume. Powder enters the open end of the dosator and is slightly compressed against the piston into a plug. The machine that works on the principle of dosator feed are Zanisi, MG2, Macofar, Fermatic, Pandini and Bonapac. This is the schematic representation of dosator feed method of capsule filling. Dosing disc and tamping finger method. In this method, a dosing disc forms the base of the revolving hopper. The disc has a series of accurately drilled holes. A powder plug is formed by a set of metal rods which are lowered into hole through the powder bed. The plug is formed by a series of tamps. At each tamp, finger pushes the material into the holes before the index into the next position. At the sixth position, the plug is pushed out into the capsule body. Filled weight can be varied by adjusting thickness of dosing disc, movement of the tamping finger and pressure applied on the tamping finger. The machine that work on docent disc and tamping finger method are Holy Finger Karg Harrow finger. This is the schematic representation of the method. The next method is vacuum filling method. Perry Industry developed the method based on their ideas of using vacuum to fill powder in vials by technique called AUGER-FILL. Example, Perry capsule filling machine. The machine that works on this principle is known as Osaka. This is the schematic representation of filling of capsule by vacuum method. Fluidizer method. A vibrating plate is placed inside the hopper which fluidizes the powder, causing it to flow inside the capsule body at a uniform flow rate. Example, Osaka capsule filling machine. This is the schematic representation of fluidizing method and the Osaka model R180. Capsule sealing. There are two methods of sealing capsule. The first one is heat yielding process and the second is liquid wetting agent. In heat yielding process that fuses the capsule cap to the body through the double wall thickness at their junction. The process results in distinctive ring around the capsule where heat welded. In liquid wetting agent that lowers the melting point in the contact area of the capsule's cap and body and then thermally bonds the two parts using low temperature. Cleaning and polishing of capsule. On small scale, capsule may be cleaned individually or in small number by rubbing them with a clean gauze or cloth. On large scale, many capsule filling machines are fixed with a cleaning vacuum that removes any extraneous material from capsule as they exit the equipment. Industrial cleaning and polishing of filled hard capsule use the Elanco apparatus. Formulation. The size of shell should be chosen by considering the bulk density of the material. The color used in the shell must be different to provide product identification. The flow property of powder should be adequate for that particular method of filling. The chance of drug excipient incompatibility must be anticipated. The reaction should be studied at elevated temperatures and pressure. Quality control of capsule. Whether capsules are produced on a large scale or a small scale, all of them are required to pass through certain tests, and that is quality control test to test the quality of finished product. Physical test. Physical tests include disintegration tests and weight variation test. To evaluate capsule chemically, chemical tests are performed. Chemical tests such as dissolution test, content uniformity test, moisture penetration test, stability testing are tests that are performed. Physical test for capsule. Disintegration test. In these tests, the test determine whether the capsule disintegrate with a prescribed time when placed in a liquid medium under prescribed integral conditions. Weight variation tests. Limits for the weight variation tests are not more than 2 of difference are greater than 10% of average net content. No case is difference greater than 25 weight range. Chemical test for capsule. Dissolution test. Dissolution test is carried out using dissolution apparatus official in both USP and IP. The capsule is placed in a black basket and the basket is immersed in a dissolution medium and caused to rotate at a specified speed. 6 capsules are tested and are accepted if each of them is not less than monograph specified, that is P plus 5%. Factor affecting drug dissolution are dissolution rate of the shell, rate of the penetration of dissolution media, nature of primary drug particle. Here is the representation of capsule that dissolve from starting to 10 minutes of 10 minutes after the capsule is immersed into the dissolution media. In this picture, we could see the disintegration that occurs from 0 minute to 15 minutes. The next test is content uniformity test. In this test, 10 capsules are taken and are subjected to assay. 9 to 10 capsules should be in the range of plus or minus 15%. If 10 capsules are beyond plus or minus 15%, then 20 capsules are assayed. All capsules within range of plus 25%. Then next test is moisture penetration test. The degree and rate of moisture penetration is determined by packing the dosage unit together with a color revealing desiccant pellet. Expose the pellet unit to known relative humidity over a specified time. Observe the desiccant pellet for color change. Any change in color indicates the absorption of moisture. By measuring the pre-test weight and post-test weight of pellet, amount can be calculated. We are thankful to Dr. Shivajirao Zondre, President of our college, Dr. Geeta Khare Ma'am, Secretary, and Dr. Nitin Mohire Sir, Principal and Professor of our college, for encouraging us to make such informative videos. If you like the video, please like, share, and subscribe to our channel.